After the interstellar object 3, I/ATLAS, crossed into our solar system, researchers have been scrambling to capture every possible observation. So far, measurements suggest this enigmatic visitor is racing past the Sun at roughly 61 kilometers per second, potentially the fastest natural object ever recorded here. Most astronomers lean toward a simple explanation. It's an interstellar comet now evolving as it nears the Sun. Its tail has lengthened, and its coma, the diffuse envelope of gas and dust around the nucleus, has become increasingly prominent. All of that tracks with a comet blazing by at breakneck speed. But a recent twist has raised eyebrows. Capitalizing on this week's total lunar eclipse, comet hunter Michael Jäger and colleagues used Namibia's dark skies to capture deep images of 3I/ATLAS. Their data indicate the coma's dominant glow has shifted from red to green. Early observations showed a reddish hue seemingly tied to the surface rather than a dust cloud. Now the color trends distinctly greener, behavior not seen in previous interstellar visitors. One hypothesis is that fresh surface chemicals are vaporizing. On August 25, 2025, the Very Large Telescope reported a sharp uptick in cyanide production around the object, a change that could explain the move toward a green-blue tint. Stranger still, researchers also report detecting nickel without accompanying iron, a combination uncommon in natural comets. On Earth, nickel without iron is typically associated with industrial processes, prompting provocative questions about whether 3I/ATLAS is entirely natural or something engineered. The mystery deepened on September 7, 2025, when a new photo showed an unexpected anti-tail, light extending toward the Sun instead of away from it. This isn't an optical fluke, and it stirred fresh arguments among astronomers. Some propose that as 3I/ATLAS approaches the Sun, the sunlit face heats unevenly and starts releasing not just gas and dust, but larger ice fragments. Because these chunks are heavier, the solar wind can't whisk them away as easily, allowing them to linger and even spread sunward. Sunlight scattering off this debris creates the odd inward-pointing glow. In plain terms, mixed particle sizes plus intense heating could produce the anti-tail. One more twist? The object's true dimensions remain uncertain. Early estimates put 3I/ATLAS's diameter somewhere between 3 and 10 kilometers, already in the league of our largest comets. Then a newer analysis stunned researchers by suggesting a nucleus as big as 46 kilometers. Inferred sizes in the 20 to 46 kilometer range would make it up to 1,000,000 times more massive than previously seen interstellar visitors, a scenario some consider unlikely given the scarcity of raw material in interstellar space. That outsized scale is one reason a few scientists are open to the idea that this may be more than a typical comet. Its timing adds intrigue. On October 3, 2025, 3I/ATLAS will pass near Mars, offering a rare close-up window. Even before that encounter, observers report odd behavior as it nears the Sun. Shifts in brightness, chemistry, and even shape, prompting questions about whether it might respond in unexpected or seemingly unnatural ways to planetary gravity. How could that happen? Two speculative possibilities are discussed. If it's technological, it might execute maneuvers, though none have been detected so far. Alternatively, it could release secondary objects aimed at planets while the main body continues on toward another star. One more curiosity, its inbound path traces back to the constellation Sagittarius, the same region associated with several enigmatic radio detections, including the famous 1977 WOW signal. That directional overlap has certainly caught the community's attention. Another twist lies in its flight path. Most interstellar passers-by cut through the solar system at steep angles, but 3I/A TLAS is gliding almost right along the ecliptic. Its inclination is under 5 degrees. By chance, that kind of alignment is roughly a 1 in 500 roll. Conveniently, the route carries it past Venus, Mars, and Jupiter, as if charted in advance, much like Voyager's carefully planned grand tour. The strangest timing comes at perihelion, when 3I/A TLAS is closest to the Sun. Earth will be on the far side, maximally distant. To some, that feels too tidy, sparking speculation about an artificial trajectory. Scientists stress there's no proof yet, but it's worth watching closely. As 3I Atlas draws closer to the Sun, it could either follow the predicted trajectory or pull a surprise by changing course while hidden behind the Sun. Such a twist could upend what we think we know about this enigmatic visitor. For now, it looks comet-like, yet it behaves in unusual ways. It seems larger than most known comets and may be extraordinarily ancient, possibly older than the solar system itself. That would mean it has roamed the Milky Way for billions of years, long before the Sun and planets formed, passing through supernova debris and various interstellar clouds and gradually picking up or being coated with diverse materials. This mosaic of substances could explain its odd chemistry compared with typical solar system comets. Researchers plan to study the object during a very close pass by Mars on October 3, 2025. NASA's Mars Reconnaissance Orbiter is expected to try for images with its powerful camera. Even with a resolution of about 30 kilometers per pixel, too coarse to see fine details, the observation should still be informative, including whether the object emits its own light or simply reflects sunlight. If successful, it could mark the first time an interstellar object is imaged from another planet. Additional chances to observe it may come in late 2025 from spacecraft such as NASA's Psyche mission and ESA's JUICE probe. That's all for now. If this video interested you or taught you something new, please share your thoughts in the comments. Your opinion is very important to us. Subscribe to the channel. Thanks for watching.